2.7. Analyze the changing acceleration of a rocket during launch in terms of the law of conservation momentum and the forces experienced by an astronaut. This PowerPoint or video goes over 2 slides, so stay tuned within this video for the next slide about forces experienced by astronauts. So look at the diagram on the right hand side. It's demonstrating Newton's third law, which is for every action there's equal opposite reaction. So during a launch of a rocket, as the rocket is moving upwards, there is exhaust gases moving downwards, and that is the action-reaction force, okay? So that there is explaining the changing acceleration of a rocket. However, it doesn't clarify what happens about the fuel. So as the fuel is being burnt, the rocket decreases in mass. As the rocket decreases in mass, the acceleration increases or the velocity increases. Now, what does this mean for the people on board of this rocket? Well, they experience a force, and this force is due to the thrust force from the rocket engine, which remains constant throughout the burning process. But the total rocket's mass decreases due to the consumption of fuel, which I just mentioned. Then the acceleration increases greatly. Okay, so what do these astronauts experience? They experience an increasing g-force. So it begins with 1g, and then we're experiencing 1g at the moment. And then it goes up to 2g's, and then as acceleration increases, they experience up to 5g's for several seconds, okay, or up to a few minutes. And as the rocket burns through its fuel, that g-force on the astronauts is increasing due to the amount of acceleration that rocket is experiencing within the Earth's gravitational field. Okay, so those are the main forces acting on an astronaut, and that is the g-force